Okay, so this video is going to walk through the estimating of the best fit line for two interval level variables. So I've kept my high school year completed for the father and the number of hours worked last week for the respondent. And we're going to see if these two variables are related to each other. I have already cleaned up the missing data, so that's a good thing. And so what we need to do is, first I want us to do a scatter chart, just to see what the data looks like, see what we can see about what the data looks like. We may not be able to see a lot. When you do the chart, the first thing you get is this line chart, which is not useful at all. And so I would have you go into the chart type and choose scatter chart. This is a little bit, I actually am going to guess there's no relationship between these two variables, but we'll know when we do the best fit line what it actually looks like. And I'm going to give it a title that makes sense. And so that is Respondents' Work Hours by Father's Education. And we have the highest year of school completed for the father on our x-axis and the number of hours worked last week on our y-axis. And one would expect the x-axis to be the independent variable, or the cause, and the y variable on the y-axis to be the effect, or the dependent variable. So what we need to do now that we have drawn the scatter chart is we need to compute the best fit line. You have a template out there now. You can link to it through Moodle, which will take you to the calculator for the best fit line. And so I'm going to take that calculator. I'm just going to copy it right into my spreadsheet. And then I am going to put the correct line estimation in. So my data goes from 2 all the way down to line 1028, so those are my ranges. So I'm going to say equals line estimate A2. Oops, I'm going to do the dependent variable first, so hours worked first. So B2 to B1028, and then A2 to A1028. That will do the estimate of the best fit line for those two ranges of data, and I insert the two true statements so that I will get the output that I need. And so what we see, ooh, this is interesting. So what we see is we find a slope and we find a y-intercept. Our y-intercept is at about 39 hours. So when the father's education was 0, the line crosses the y-axis at 39. Remember, what you want to do as you look at this is you want to compute some values of y for different values of x. And I would choose for my x values that are actually on your axis. So 5, 10, 15, and 20. So I'm going to put in 5 and 10 and 15 and 20. And these are going to allow me to plot a line here. The equation for the line is going to be y. So that's just going to be y equals the slope times whatever the value of x is plus the y-intercept. So my hours worked last week is going to be equal to father's education times 0.19, which means that for every 5 years of father's education, we would see 1 more hour worked. So there may be an upward, a positive relationship here. So because 0.019 I'm sorry, 0.19 times 5 is about 1. So that 0.019 represents about 12 minutes out of an hour. And then everybody's sort of starting at this y-intercept of 39.06. So that's the formula we're working with. And we can create that formula in our box with our value that we can compute some different values of y. So y is the slope, which is 0.1972, times the years of the father's education plus 39.06. And then we can take that formula and we can copy that formula into each of our cells, and it will compute the new value. So at 0, we're at about 39.06. At 5 hours, we're at about 40, then 41, 42, and 43. There is an upward trend here. If we want to see if that's statistically significant, we've got to put the t-statistic for the slope and its degrees of freedom into a calculator. So the t-statistic is 1.75, and the p-value is 1,025. So the t-score is 1.75, and the degrees of freedom is 1,025. We're going to make that a two-tailed test. And it is not significant at p less than 0.05. It's close to significant, but it is not significant. But what we have done here is we have shown how we can use the line estimate command to create the line that best fits the data, and we can see, using the formula for that line, what happens at different levels of the x variable, or in this case, father's education, what happens to hours worked last week. And while we can say that for every 5 years of father's education, hours worked last week goes up by 1 hour, we cannot generalize that to the population. We cannot be confident that that exists in the population.